Yes, welcome to the class, my dear students. Today I wanted to give a glance on R Studio and R programming. So this is what the environment of R language, R Studio. Now there are four places here, four windows are open here. So in this, the first window is the source window, and whatever the codes you are typing here, and that will be displayed here in the environment as well as in this is called as the console, and this is the source, and this is the environment. Global environment is this, and this is where you will whatever the plots you will be giving, and those plots will be displayed here. So this is what the first the platform of R programming. And then now let us come to the basic commands. Already we know what is meant by how to do the product. Means if you want to multiply 2 and 3, then you will get 2 star 3. And if you want to 2 star 3, and the powers means the crowns, and then the square roots means sqrt and all. So all those basics, actually whenever you are start typing the particular command, then it will automatically, by default you will get some prompts there, so that you can do it very easily. So in today's lecture I want to give the frequency distribution, how to for the given data, how can we construct the frequency distribution, and then the histogram, and how to plot the ogive curve. So these are the things I am going to discuss in today's lecture. So now I just wanted to explain the code, and then we will start operating the code. Let us see now the code is like this. So try to understand the code. The code is, suppose we wanted to construct a frequency distribution table for this given data. So for this data, when I give, then it will give the range. We wanted to find out the distribution means the minimum things are what is the minimum value, what is the maximum value, and what is the range. And then we will print the range. So all these, so minimum, maximum, range, all this. And the length means the number of data values, the length of the number of values, how many are there in the given data, that gives you the length. So let us now give this commands up to here, so that what it gives us, let us see. Now let us start execution of this. So when I give x values are the data values are this, and then to calculate the range, the number of classes and the class width and all, we are now going to do the minimum, the name of the variable. You cannot give the space, or you cannot give any other characters in the variable names. So whatever the variables you are giving here, immediately on the environment, in the global environment, you can see what are the variables here. Similarly, now I have given the variable name as mm. So it is the minimum value of x. So let us run this. What is the minimum value? It gives you 7. And what is the maximum value? The maximum value is 94 in the given data. And then what is the range? The range is maximum minus minimum value. That gives you the range. Then if you say print r, then that will be printed in your console also. Here, of course, you are getting in the global environment whatever the variables and their values. Here in the console, you will be, whenever you print immediately, it will be displayed in this console also. So now I wanted to find out the length, how many data values are existed in our data. So that means I name that n as less than minus. Less than minus is the syntax of R, correct? So n minus is the length. Length means length. See, it is already prompted here. By default it will be prompting, so you should only the value, so you have to put properly. So the length of x is what actually it is given by n is equal to 17. This L denotes the integers. Okay. Now if you are able to understand one thing, here whatever you are typing, you can type here, whereas you can edit here, whereas here you cannot do anything. You cannot copy also. Even in the console also you cannot copy whatever you have, the data, whatever the programs you have done here, whatever the code you have given here. This in the console area you cannot copy or paste anything. So what is the editable area is only this source area. Okay. In the source window only you can edit. Okay. And then let us come to the, what is the next command to find out the length. And length is over. Now I wanted to find out the class. The number of classes is given by the formula 1 plus 3.332 times of, that means multiplication, log of n base 10. N is what? The number of data values, which is that is the length. So now I am giving you that the class is this, and then what we need is, generally when we theory also we have done that, that is the round of the number of, round of the number of classes. That means if you get 2.2 suppose, then it will round to 2. If you get 4.2 suppose, it will round as 4, like that. And number of values, so that is what the number of values in the classes. And then when you start print the class, you will get the print of the class. Up to here I will just see that what is the width also we can find out. Let us now go to the this one. So now after the length it is printed. Now I wanted to find out what is the classes. The formula is what? 1 plus 3.332 star log of n. N is what? It is n is the number of values. It is 17 base 10. So that value you got it already. That classes is 5.09. Now I want the round of 5.09. The round of 5.09 is 5, correct? So now let us see, print the class is over. Now print the this one class. So now here round of CL digits is equal to 0. That means after the point you should not get any values. That is what print digits is equal to 0 means. So now if we start print class, then you can see, yes, see it is rounded. The value of class is 5.099, but when you round it is 5 now. Now we wanted the width. Width is what? The range by the number of classes. What is the classes we have got? 5. And the range is what? Range is how much? It is 87. So 87 by number of classes is 5. So for that the ceiling. What is meant by the ceiling? Ceiling of a number is always the immediately greater integer. Suppose if you have 5.6, 5.6 ceiling will be 6. If you have 4.7, the ceiling is 5. If you have 4.3, ceiling is also 5. So these are all the fundamentals I have discussed in the class itself. Now let us see what is the print width here. The width is what? The width is now given by 18. So we have printed the width also. So now the total width is 18 you got. So we have got the classes also 5. So with the width of 18, with the number of classes 5, we are going to arrange the data into the so and so types of bins, or we can say the class intervals or something like that. So now see this code, a bit easier code, and try to understand this. This holds for every problem. So now what we define the bins? Bins as what? Sequence. The sequence is what now? We start with the minimum value and then maximum value. Suppose if you write the minimum value and maximum value, it may not be with the same width 18, right? Always. So what we do, the maximum value plus width we do, and the difference is always width. So here our minimum value is what? Actually 7, right? 7. And then we have to see that width. 7 plus 18 is 25. 25 plus 18 is 43. Like that, up to which number? The maximum value plus width. Like that we will say. Now look at this now. Let us see now by this particular code what happens. This. So the bins are the sequence of minimum, maximum plus width by equal to width. So with the width 18, we are going to get the values. So let us now see here. Now see in the environment you are able to see that there is 7. First number minimum value is 7. Plus 18 is 25. Plus 18 is 43. Plus 18 61. Plus 79. Plus 97. Now up to here we have got, because we have given this one values. And now let us go to print bins. Print bins. You see the bins I have got all the bins now. 7 to 25, 25 to 43, 43 to 61, 61 to 79, 79 to 97. So totally 5 bins I have got. That is 5 classes I have got, as we have got the problem here. Now let us come to the, after getting the bins, we need to find out this, actually our frequencies whatever are there, that should fit in this intervals, correct? So let us write down those are the labels as. So we are customizing the labels actually for the bins. Okay. So when you do this, it has to sit in that particular interval. So that's why we are giving this command as labels we are giving, that is what, 7 to 25, 25 to 43, 43 to 61, 61 to 79, 79 to 97. So totally I have got 5 classes. Now let us go to this one. And now our job is to make the values, these x bins whatever we are taking, this should go and cut into that particular value. What is the meaning of this, I will tell you now. See here, this is x bins, that means whatever the given data name is x, that we are segregating them into the bins. What do you mean by bins here? Cut means that values are cutting by the given data x. The breaks are is equal to the bins, whatever the bins we have given here. These are the bins are the breaks, and the labels are whatever the labels we have given here, these are the labels. So that means this is the command you are giving. And right equal to false, what do you mean by right equal to false? Then here in this interval you have left and right. The left interval is what, the left boundary is 7, the right boundary is 25. Here the left boundary is 25, the right boundary is 43, correct? So what do you mean by right is equal to false? Means the right interval, the right boundary is not included in this interval. Here also 43, if suppose if you have got a 43, the data is 43 is there suppose, then this 43 will not be included in this interval. Similarly 61 will not be included in this interval. So that's why the command here is right is equal to false. Then it is very much clear that that number 25 will not be included in both the classes. 25 will be included in this class, whereas 25 will not be included in this class. So such a clear explanation it gives about the bins. Now when you write this command, let us see what happens. So this gives you the bins. Let us execute this. So this is what. Now let us say we have to print the bins now, this one. So let us see the frequency distribution now we will do. What is the table of x bins? So in this frequency distribution, we get the table, whatever the values we have now constructed with the table of x bins, we get the results. So let us see now, print the frequency distribution, print of frequency distribution. Let us always try to copy the above this one, because there is, if there is any spelling mistake or something, then it will not read and it will give you an error. So better always copy the previous whatever the name you have given, that if you do, then we will be saving the time. So look at that now. It is 7 to 25, there are 5, 25 to 43 2, 43 to 61 6, 61 to 79 2, 79 to 97 2. Add all of them, that is 7 plus 6 13 plus 4 is 17. The total number of observations n is equal to 17. It is tallied. So we got the frequency distribution now. I hope it is clear now. So with this is what the commands you have to put properly. From here it is a bit confusion all of you faced in the class also. So therefore always this is the minimum value. Sequence is minimum, then maximum plus width, and then by equal to width. And then labels we have to give, we have to customize these labels, then only it will understand the bins actually. So what is the customizing of the labels? You have to say what is the minimum value, 7, then the width is 25, sorry 18. So 7 to 7 plus 18, then like that it goes on. Okay, now let us go to construct the let us plot the histogram now. So we have printed the frequency distribution, we got it now. So let us now, histogram is what, let us see, this is the command. Hist is a command for histogram. Now we are giving x comma x is the data, and breaks we have given the breaks as bins. Breaks is the command you have to give to understand for the histogram construction in R. So it is breaks equal to bins. And color, the color is what we have given red. X label is x, y label is equal to y. So if you give this, then we are going to get the histogram. So let us now take this as a command, and then let us start here. is what the histogram. Hist of x comma breaks equal to this. Let us see what happens here. So now this is what you observe now. Hist of x comma breaks equal to bins colon color is equal to red. X label is what x, y label is equal to y. And try to understand here. We have got 7 to 25. That means somewhere 7 to 25. How much is the frequency? It is 5. And then 25 to 43. 25 to 43 somewhere here. The frequency is what? 2. 25 to 43 is 2. And then 43 to 61, the frequency is 6. And then 60 to 61 to 79, the frequency is 2. 79 to 97, the frequency is 2. So observe that there are 5 classes here, 5 bins are there now. It is very much clear now that the histogram has been plotted, and the data also, when you add all of them, see here, that is 5 and this is 2. 5 plus 2 7, and then 7 plus 6 13, 13 plus 2 15, plus 2 17. If you add all of them also, it is perfectly fitting with our data values. So this is what the construction of the histogram. And then we have to construct the ogive also. For the ogive curve, we need the frequencies, correct? So the cumulative frequencies. So cumulative frequencies is denoted by the cumulative frequencies are what now? CF is the notation. We have given the variable name as CF, and C is the that particular sequence with the 0 comma, with the starts with the sum, means cumulative sum of what? Whatever the frequency distribution we named, that one. So let us now run this. So this gives you this. Now what is the print of CF if I give? Then it will give you totally the value. See, because 0 means whatever the values below this minimum value is 0 only. That is what the understanding here. And 5, 7, 13, 15, 17, these are the cumulative sums. And then you have to start plot. Plot is what? Bins. CF is the cumulative frequency. The main is equal to, what is the main? That means here what is going to be plotted here. The main is given by the ogive plot. X label is X, Y label is Y. Understand that whenever you are writing down a text, it should be in the quotations always. So this is what the command here. Let us see what happens to our, yes, we have got the ogive plot, and we wanted to connect all these dots, right? So to connect this, we have given the command as lines of bins comma CF. That means the bins, whatever it is there with the lines, with the cumulative frequencies, you are now going to connect them. So this is what the ogive plot. We have got the now histogram also, ogive plot also. I hope it is very much clear with this lecture about the how to construct the frequency distribution table, and then how to construct the histogram and the ogive plot also. Please understand, this is very much important. The construction of the bins, and then construction of the labels. Labels we are giving by ourselves according to the data. So this is what the today's lecture. Thank you very much.